Hello, let me introduce myself. I'm Yafet Sambara from the Information Systems Study Program Class B with student registration number 241011060048. I want to discuss about computers, transistors and transistor principles as well as 3 logic gates in this video. Enjoy! Here, we can see several computer hardware components: the speaker, keyboard, monitor, and below them is the CPU. A computer also has other components inside the CPU called the mainboard. Inside the motherboard, there are also computer components known as transistors. And now, let's discuss together the principles of transistors or the 3 logic gates. Let's watch the following discussion video together. The phenomenal semiconductor is the transistor. Transistor is a semiconductor device that is used as an amplifier, as a circuit breaker and current switch, voltage stabilization, and signal modulation. The transistor was invented by John Bardeen and Walter Brattain in Bell Labs in 1947. Since then, electronic products are using transistors and their sizes are getting smaller. Briefly, the transistor works like this. It is in the off position. Here the transistor functions as an insulator. This is in the on position. The transistor functions as a conductor. This is the off position again. In a smartphone, there are about 2 billion transistors. The AMD EPYC Rome processor, produced in 2019, has 39 billion transistors of size 7 to 12 nanometers. The current smallest transistor is claimed to have the size of 1 nanometer, which is smaller than a virus, produced at Lawrence Berkeley National Lab, USA. A logic gate is a device that acts as a building block for digital circuits. They perform basic logical functions that are fundamental to digital circuits. Most electronic devices we use today will have some form of logic gates in them. For example, logic gates can be used in digital electronics such as smartphones and tablets or in memory devices. In a circuit, logic gates work based on a combination of digital signals coming from its inputs. Most logic gates have 2 inputs and 1 output, and they are based on Boolean algebra. At any given moment, every terminal is in one of the 2 binary conditions, true or false. False represents 0, and true represents 1. Depending on the type of logic gate being used and the combination of inputs, the binary output will differ. A logic gate can be thought of like a light switch, where in one position the output is off, 0, and in another, it is on, 1. Logic gates are commonly used in integrated circuits, IC. Here are the logic gates. The NOT gate gives as output exactly the opposite of the input. The AND gate gives as output 1 if both inputs are 1, otherwise 0. The OR gate gives as output only 0 if both inputs are 0, otherwise 1. The NAND gate is the NOT AND gate, which gives as output only 0 if both inputs are 1, otherwise 1. The NOR gate is the NOT OR gate, which gives as output 1 if both inputs are 0, otherwise 0. The XOR gate gives as output 1 if the inputs are different. It gives 0 if both inputs are the same. Thank you for watching this video. Don't forget to like, subscribe, and leave your best comments so we can learn together and have more fun.